Hi guys, welcome back to another video. Back on the VFR NC30 build. Working on the barn find one today. I got a couple of parts as well, so happy days, we can move forward. Today I want to work on valve timing. I've got a couple of parts to put on the bike, which is mainly one more valve I need to install. I was waiting for a part for that. And then I can put on the rear head. I think it's the rear head I need to put on with the cam gears and all that stuff. Torque that down, and then we'll be able to do our measurements. So let me show you guys a couple of the parts that have come in. I've been waiting for a long time from these. They've finally arrived. Now we can get onto the bike. So here's a couple of things. So some of the boring parts out of the way first. I've got some new exhaust studs for that same particular head. I had a set of them. I could only find 4, so I had to buy another set. I've installed 4 on the front head. I need to put 4 new ones on the rear head. So that's that. Also, these are the exhaust seals gasket sets. So these go in between the manifold and the engine block. And then obviously they're copper, so once they're compressed tight, then they form a seal. So we need to replace these every time we replace or take the manifold off. So 4 of those for the 4 valves, for the 4 heads. Also, I've got a new magnetic, I think this is magnetic, yes it is, and an oil sump bolt. So I'm replacing the old rusty one that was on there. It's got the washer with it as well. So that's ready to go on. This is something I've been waiting for ages. It's OEM parts, so sometimes take a bit longer to get hold of these. But these are the seal kit for the water pump. So this is the one that seals it between the engine, and this is the one that seals it between its lid. So now we can put the water pump back on, which is bringing us one more step closer to being able to crank this engine up. Also, for my other bike, the other NC30, you might have noticed if you've seen one of the previous videos, I think the one before last, where my neutral switch failed. And I did diagnose that to a neutral switch. So I bought a new neutral switch for that. So I'll be installing that at some time on the other bike. So look out for the video on that. And also, an important part I've been waiting for are these parts. They are cotters, and these are, you have 2 of these per valve. Now, I lost one of these. They are tiny. One of them went flying somewhere, and I lost it. So, hence why I've not been able to put that last valve in, which is preventing me from putting head on, which is preventing me from doing my measurements, my clearances. So, I bought 4 of them, so I've got some spares. I'm going to install that valve in now and get this head on, and hopefully we can get these clearances done today. Once I've done the clearance measurements, I will have to have a look at all the shims that I've got. Some of the shims I might be able to move around into other places. Also, I've done an Excel spreadsheet, which is going to help me calculate by itself, once I put in the data, what size shims need to go inside what valves. So I will I'll make that spreadsheet available if anybody wants it as well. They can get it from me. I can email it to them as well. So yeah, then, but also another thing I lost is one of the shims, 1 or 2 shims I think I lost, I can't remember. So I am going to need to at least get 2 shims. Hopefully I wouldn't need to get too many, and I can reuse some of the other ones if they can move and fit somewhere else. All right guys, so without further ado, let's get on to the bike. So we've got a new gaskets. I put that valve in, so I'll show you guys which valve it was. This one there, and there's the cotters in there. You can see them inside there. That's what holds the spring in. As you can see, I lost one of the shims. Well, I'm gonna have to measure all these shims, and they're all gonna probably have to get moved around anyway. All right, so these all torque down to spec, 36 Newton meters. And then we've got these 3 bolts, which are 12 Newton meters. So 12 Newton meters on these 3. So what we're looking for is here, T2 is pointing to this little mark here. It doesn't look like it's lined up because of the way the camera is, but when I'm looking dead on, it's actually here. If I put the camera a little bit more to the side, that's what I'm seeing here. So that's done. And then it says to make sure that these 2 marks are lining up away from the engine, which is where they are. Again, so these are in the correct place. Now we turn the engine 630 degrees clockwise. That's 1 3/4 turns until the T1 mark aligns and the lines on the front shafts face forward at about 3 o'clock. So I'm going to spin this clockwise 1 3/4 turns, and what I'm looking for is these marks should be pointing at 3 o'clock. So once we get these at 3 o'clock, it should be 1 3/4 turns. Let's see if that marries up.
Clockwise. So we're gonna go all the way around 1. That will be 1 turn. This is 1.
All right, guys. So I've done that. So basically I've aligned T1 with the mark, which is off 1 3/4 turns. And this is roughly 3 o'clock. Obviously the engine at the moment is tilting about a bit, but if it was a bit straighter, that would be more like 3 o'clock. But I'm going by the mark here, T1, and I think we're pretty much correct now. So now that we've got that, we are ready to install the rear camshafts. And it says to make sure that they are lining away from the head, just like these ones were before. So that one is incorrect. So we've got B here, and we've got, should have A here. So we've got A here and B here. So B's here and A's here. So it goes this way. Again, I've got to line up the marks here. You guys can see it. It's got to be pointing upwards that way. All right, manual says to torque all these bolts down to 12 Newton meters. Right, I should be able to turn this engine over and not hit any pistons to valves. I pretty much think I've got it right. I will double check again. So we've got a T1 mark and we are bang on line here, about 3 o'clock on that side. So if I turn this round now to T2 until I get this round to 12, I think these end up at 3 o'clock. So let's slowly turn it. Let's see. Right, this is at T2 now. This is straight up, and these are now about 3 o'clock that direction. So I'm going to give it a couple of turns by hand. It's turning quite freely. So far so good. I think I'm happy with that. Okay guys, so I'm ready to start measuring out these clearances. I've made a little diagram. So this is the front of the engine. So these will be the exhaust valves on that cylinder. These will be the inlet valves on that cylinder. Exhaust inlets, exhaust at the back, inlets, exhaust inlets. So what I'm going to do is measure the clearances, and I'm going to write the clearance next to each of these, and then I'll take all the shims out and I'll measure what the shims are, and I'll be able to calculate from my Excel spreadsheet what shims could go in what places, and then we'll figure out if I need to get any more shims. So I've got a set of feeler gauges here, various sizes. I'm going to check the manual now and see what the specification should be. So hopefully if someone ever inspects them, we won't need to take them out. So our manual says our valve clearances with a coal engine. Inlet valves should be anywhere between 0.12 and 0.18. And our exhaust valves should be between 0.21 and 0.27. So it'll be interesting to see how many of these are actually in spec after I've moved all these shims everywhere. So I've got to work on this cylinder at a time. I'm going to go from cylinder 1, then cylinder 2, cylinder 3, sorry, and cylinder 4. So the setup for cylinder 1 is to set the mark at T1 and to have these away from the engine. So those marks that I did earlier pointing upwards, and that brings this to top dead center on compression stroke. So I'm going to measure the inlets and the exhaust valves on cylinder number 1, and I'm going to write down the measurements, and then I'll obviously set the timing for the other ones according to manual, and I'll measure those the same way. So we know for our inlets the specification is 0.12 to 0.18. So I'm going to start with the middle, 0.15, and let's see what we get on the inlets. So too tight here and too tight here. I'm expecting some of these, well, they should all be tight because obviously I've ground down the valves, so I've closed the gaps up. So I'm going to move down one to 0.13. Let's see. Still too tight. This is on the inlet. So let's go down again. Next one down I have here is 0.13. So next one I have down is 0.10, which would be out of spec. So we're just getting 0.10 in there. Slight drag. So I'm going to go for 0.10 on this one. Still not fitting on the other one. so we're gonna have to go down again. Next size down, I've got 0.08. Just a bit too tight. So we're going one more down to 0.06. And that's better. So 0.06 on this one. Now our exhaust valves, the bottom ones here, we should have between 0.21 and 0.27. So I'm going to go again in the middle, and I'm going to go 0.24 if I have one. Probably 0.25 is probably the closest I have. That's too tight. This is the one that's missing the shim, so I can't actually measure this one because it's missing a shim. What I'm going to do is I'm going to borrow a shim from the top one that we've measured. I'm going to put it down there so that I can use it to get a measurement. To take out the magnet. So I've taken that shim from up there. I'm going to borrow it down here. Alright guys, so I swapped that shim. So I've got to remember that I'm going to use that same number, whatever the thickness of that shim is. I'm going to use that for my calculations for this cylinder valve and this one. So 0.25 is too thick, so we're going to go down. Next size down to 0.23. It's also too thick. Let's go 0.2. It's just starting to bite, but it's still too thick. We'll go 0.18. Still too thick. 0.15 is perfect. Perfect on the left one. Even just 0.08. 0.06. With right down to 0.05. We're at 0.05. 0.05, which is massively out. But I suspect that shim is quite a thick shim there, so that probably was not the shim that used to be there. Right, so this side cylinder is done, all four. Now I'm going to go on to the next. So I'm going for cylinder number 3 now, which is this cylinder. So we're going to rotate clockwise again, back to T1 again, but now we want this little mark here to be facing down towards the cylinder. So basically done a 360. We're back at T1 again, and now this little mark is facing 180 from where it was before. So now I can measure and do the same thing again on cylinder 3. 0.15. Another too tight. And there we fit 0.04. So now exhaust valves, we start in 0.25. Too thick as expected. 2.3 as well. 0.08 and 0.08, both the same. So now we're working on the front cylinders. So manual says we are now doing T2 mark, and we want the T2 mark to be facing at where it's marked, and the mark here should be facing away from the engine, so it should be lining up with this line here.
Right, so these two, I can't get any gauges through there. So I'm going to come back to these by installing some smaller shims in these ones, and hopefully then I can get readings. But I'm going to move on to cylinder number 2, and then I'll come back onto this one. So we start with the inlets again. I'm going to go for the 0.15. So we've got 0.06 on both of these. So these two exhaust ones as well, I can't get anything in. So they're probably been ground down so much because some of them were so rusty. So again, I'm gonna have to put some smaller shims in these two, and hopefully I can get a reading. All right guys, so I'm gonna take these shims out and I'm gonna do some measurements of these shims. I do have one of these, so I can measure the sizes of each shim. Alright guys, so I've taken all these shims out. So this is the front of the engine, and these are the shims in the order. So these are the exhaust ones, left and right, inlet ones, inlet, exhaust. Obviously I'm missing one. This one was the one, sorry, this one used to be here. I measured my clearance there, and then I moved it here and I measured the clearance. So the shim size is the same. Whatever this one is was the same here. So at least I know which one it is. Now I need to find two, probably the thinnest ones, and I'm going to use them to get those last two that I couldn't measure. Right guys, so I'm all done of the measuring, and I'm now going to go through, measure all the shims. I've taken all the shims out, and I'm also going to put the data now into the spreadsheet, and let's see what numbers we come up with, and see whether any of these shims are going to be usable. I think probably they won't be, I might have to get a whole set. How easy that is to get at the moment is another story. We're going to see if I can get the shims that I need to get. So yeah, I'm going to quickly show you guys what I've come up with on my sheet, and then I'm going to show you my spreadsheet, and then we're going to start putting the data in. This is my sheet and what I've come up with. I'll try and explain some of it. So what we got here, this is the engine. So we've got the cylinder 1, cylinder 2, cylinder 3, cylinder 4. That's the front of the engine. And then I've got the shims in order of the front of the engine. These two shims correspond to these two are these two, and so on. This is the one that's obviously missing. So the measurement is the same as this one, because I used that shim when I was doing the measurement for the tolerance for this one. So whatever that number is will be the same as that one. So here we've got our tolerances there, 0.12 by 0 up to 0.18, and for the exhaust 0.21 and 0.27. So what I'm going to do first is measure each of these shims and write them down so I can see what sizes I actually have, and see if there's any of these that I can reuse. So I've got this little meter, easy to understand once you sort of know what you're looking for. So it's got the measurements on here. So, and it's probably quite hard to see, it's probably quite small, but each of these little lines here are sort of half a unit. Okay, the top lines. So every 2 is 1. So the first 2 would be 1, the next 2 would be 2, and then you sort of turn this, and then you get extra decimal points along the line. So I'll try and do one. Let's see. Start off with this one, front exhaust on the left. And what I'll do is just put it in between, close it up not too tight, but just close it onto it. I want to get it right in the middle. Right, so here. So now I measure the one, so I've got 1, 2, so that means that's 1. Sorry, the top ones are 1s, sorry, and the bottom ones are half. So I've got 2 lines on the top, which equals to 2, and then I go to this reading here, and I've got 26. So our first measurement is 2.26. So this shim is 2.26. So I'll write it here, 2.26. And I'm using some tape here so that I can just stick them down so that I don't lose them. So I'm gonna do the next one, which is going to be quite similar, I'd imagine. This one we have 1, 2 lines, and now we are 31, 32, 33. So that's 2.33. So that's quite a big difference, actually. It's a 0.7 difference. So 0.07 difference. So if you had a 0.07 difference on here, that could bring that up to 0.15. So that big difference actually makes quite a lot. So that's that one. I'm just going to do all the other ones now the same way. 2.21, 2.21, 2.31, 2.18. See, that makes a lot of difference. You see, this is a smaller shim, and you notice that this one is the largest gap. So the smallest shim so far has the largest gap, which makes a lot of sense. All right, so we've got anywhere from 2.18 to 2.33. So we've got quite a big difference there, a difference of 0.15. So definitely some of these can move around into some of these spots. So now I'm going to show you guys the spreadsheet, and we're going to input this data into the spreadsheet and see what we come up with. Okay, guys, so this is the spreadsheet that I've come up with. So again, we can see, so here's our cylinders, 1, 2, 3, 4. And we have our A and B exhaust and A and B intake. So this is the calculation that's in the manual, and it says you got to work with this calculation to find out what shims you need. So the calculation is A equals B minus C plus D, and where this is what the book gives us. A is the required shim size, B, which is what we're trying to calculate. B is the measured valve clearance, which we have. C is the specified valve clearance, which is what it should be. And D is the existing shim thickness. So we've got all that information. So the measured valve clearance, for instance, for the first cylinder, cylinder 1, intake A, which is cylinder 1 intake A, which is that one, which according to this will be this one here, A. The measured clearance was 0.06. So in B, I need to put 0.06. Then C is the specified valve clearance. So I'm going with the middle figure. The middle figure is 0.15. So I'm going to go 0.15. Obviously, we can play about with this figure because we're allowed anywhere between 0.12 and 0.18. But ideally, we want to get it bang in the middle. Then the next figure we have is D, which is the existing shim thickness. So the existing shim thickness for this one is this one, which is 2.31. So we're going to put in 2.31. And what that comes up with, the calculation is 2.22. So we need to replace
this shim here with a 2.22. We could probably use a 2.21 because that would still keep us within our tolerance of 0.12 to 0.18. So that gives us the new figure that we need to put here. So the new figure would be 2.22. That's the shim that I would ideally order to put in this valve here. So I'll just show you one more. B, for instance, which is cylinder A, B, we measured 0.10. So intake B would be 0.10, and C is what we ideally want it to be, 0.15. That's the specification. And then the shim for this one would be this one, 2.26. So we put in 2.26 and we come up with 2.21. So what it's saying is we need to replace this shim, this 2.26, we need to replace it with a 2.21. So I could use that shim and I could put that shim here. So that's basically how we do it. So I'm going to calculate, just do all of them now off camera, and then we're going to see what figures we come up with, A, and how many of the shims that we have can be utilized, and then I'll find out how many that I need to order. Okay guys, so I'll put all the data in now. I've double checked everything. So also the exhaust clearances are different. So the intake ones are 0.15 optimally in the center of the tolerance, and the exhaust ones are 0.24 is what I'm going for, which is somewhere between 0.21 and 0.27. So that's what I've put in there. So I put all the intakes at 0.15 and all the exhausts at 0.24, and I've done that for all 3 cylinders. So these are all the valve clearances that I got for all those valves, and these are all the shims that were in those valves, and this is my calculation. I've created a formula that gives me the calculations. So what I really should be doing is these are the size of the shims that should be going in each of these banks. So I'm going to see which ones I have correspond to any of these, and obviously I can reuse those, and then any ones I don't have, I'm going to try and see if I can order those particular sizes. Right guys, so I've listed all the shims that I have. So these are all the shims I have, as well as these. And what I've done is I've moved some of them into spaces where they could be used. So where I need a 2.17, I could definitely use the 2.18. I could use the 2.21 there. I can use obviously a 2.18 there, which matches that. And a 2.21 can be used there. And also I can use that 2.2 there. Now all these other ones, actually this 2.21, I could use it up there with the 2.22. But all the rest are too big to be used anywhere. So I'm going to need at least 10 shims to replace. So I'm trying to see if I can find a shim kit with multiple sizes that will have the sizes that I need. So I found this shim kit on eBay. It's got 141 shims, got various sizes from 1.2 all the way up to 3.5. So these are sizes that you've got. I think it's got 47 sizes, and it has that 3 times. So you've got about 141 in there. So these are the sizes that I need, and these are the sizes in the kit. So some of them I'm gonna have to match as closely as possible. For instance, 2.14, I'll have to use a 2.15, which will be within the tolerance anyway. And for instance, a 2.21, I'll have to use a 2.2 and so on. So I'm looking, maybe I might order one of these. This is sort of a generic kit, but it is the right diameter, 7.48, and I did measure the diameter of these as well, and they are 7.48. Seems to be a common size. So might order this, and that would definitely have enough shims to cover me for all the pieces that I need. So guys, that is it for tonight. Hope you guys enjoyed that video. Very interesting for me, very mind-boggling. Double checking, make sure you get everything right, because the last thing you want is valves getting hit and so on. But I think I've pretty much got it right. Hopefully if I've done something wrong, someone can let me know before I put the shims back in.
So yeah, let me know, guys, what you think about the video. If I've done it right, if you've learned something, if it makes sense, if I'm doing something wrong, etc. Yeah, so I've just got to now order these parts and wait for them to come. In the meantime, literally I've just had a delivery of the new ultrasonic cleaning solution, which is supposed to be a really good one. It's supposed to take rust and oxidation off. So I'll be using that and see if I can get these carbs cleaned up. And while we're waiting for the shims, then we can get on with the carbs as well. And hopefully we can get this engine up and running. So guys, hope you guys enjoyed this video. Please let me know what you like. Yeah, please like, comment and subscribe. And I'll see you guys in the next video. Take care.